maximum. Maybe from like an arch bridge can be from 32 to 200 span, or we shall look at that. Then suspension bridge also you can see is now spanning. This one span even up to about 1,000 meters, almost a kilometer. So we have this deck suspended by cables. So load path when you are dealing with suspension, the load path is different from when you are dealing with an arch bridge. These are very unique interest reading areas that you need to look at. How are the load paths? How do you interpret? By the time you have a foundation, which are those key elements that pick loads from here, transfer to the next one, and then all the way you take it to the foundation. And then the different bridge elements. I've also tasked you to make sure the load path and the different structural element and non-structural element is important. You look at in detail, so that because tomorrow when we go into modeling and understanding, you need to know the configuration, you need to know the geometry, you need to know the different sections. So it is important. So suspension bridges are so here. They are mostly applicable in Western world, the European countries and the Asian country. But because of money, that's where the problem is. Otherwise, but I think with time, and you guys who are now getting into the bridge design world, we shall see. We have had one already here in Ginger. You're going to see down here. At least in our time, we have participated in and we have seen. But the next now should be a suspension and also an interesting arch bridge. So this is suspension bridges. We shall also look into detail when we are looking at the specifically long span bridges, and then also the beam bridge and the rest. So this is how these one they're looking. They look like. To the right is one of the longest suspension bridges in the world. It is called Akashi Kaiso in Tokyo. We have visited. Personally, I've been here I think 3-4 times. This is one of the big. We shall look at it. I will get some literature about it and share when we are getting into bridge, but not now. Now it's good to read, but also you can go and look at articles about this one. Read about them. You guys, as students, you need to research as widely as possible. Then you have cable state. Now these are the two very interesting things. When I was doing my masters, they talked the long span bridges we did. They were on the 3 dimension. They mentioned arch bridge, suspension bridge, and cable stage. And our assignment was on cable state, which I'm going to show you down here. So for cable state, they tell you that this is deck supported by cables directly connected to towers. Definitely is already giving you what? The load path. You can see the suspension is saying deck suspended by cables. So what is carrying what? What is a burden to what? And now the other one takes load where? The same applies with cable. They're saying your deck supported by cables directly connected to the towers. So now when you're looking, so some of these can now give you hints. So these I've given you our own example of the Nile Bridge. Nile Bridge was constructed between 2014 and 2018, but the design started from 2008. I want you as a bridge enthusiast, I want to look at how long, if the design pre-feasibility was conceptualized in the Ministry of Works in 2008, before when Yondra was now coming into being. From 2008, construction commenced in 2014, and it took 4 years. So how long, comparing the time for construction and the time for design, from 2008 up to 2014, those are 6 years. So now you can actually ask, that was pre-feasibility, then you move to the feasibility stage, then now you go into the draft detail design and the design, then there are issues to do with, this was funded by JICA, Japan government. So there are issues to do with securing loan, finalizing financial issues, so that could lengthen the design. Doesn't mean that they were doing mathematics for all that 6 years, no. There are those administrative procedures that have to be undertaken to secure of loan. That's why it took some time. So this is your night. This is at night. It has some lighting at night. Then this is to the right, a completed one. But of course now in future, as we continue advancing, you also get to know Like doctor said, there we still have challenges. We shall see some challenges I've mentioned down. If you ask a question, Michael, what was your contribution here? Now we shall look at the challenges. But what I'm going to tell you in one statement is this bridge was designed by Japanese government or Japanese consultant and constructed by Japanese contractor. As simple as that. Then the question now comes from your mind that said that why only Japan? Are you saying we don't have engineers in Uganda? Now you are coming. We shall support you, and then see how best we can also take the industry to the next level. So that is another type. So we have looked at beam bridges, we have looked at arch bridges, we have looked at we looked at cable state, we have looked at suspension, and then now we are going to look, I think, let me see this last one. We have truss bridges. You have seen a Pakwach Bridge. Some of you have gone to Kayunga. You have gone through Seziba Bridge. We are replacing Seziba Bridge with an arch bridge. So in the next, I think when the doctor comes around, we can get time with schedule. We shall go and have a look at some of these bridges that are not very far from Kampala. It is very important we can pay a visit. They are yet doing mobilization to start the foundation works. So it will be replaced, but it is actually looking like this type here. This is the one of linking Lake George and Lake Edward. So you have heard about Kajina Channel. So sometimes we call this bridge Katunguru Bridge. You have Butenyi on the right and Kasese on the left. Now this is a Pakwach Bridge. There are 3 spans of 80 meters. Imagine you have 80 meters from the support to this support, another 80 meters, total is 240. Currently, I was supposed, there are challenges affecting bridges during service. We have a very huge water floating vegetation, which is settled around here, pushing this to support peer support system. And the bridge is already in its progressive collapse stage. We have written letters to ministers, and we have even gotten some fund to build a temporary jetty. I think we may, if the project progresses, we can get time and run there, and we also have a look. So this is still bridges. This one is a Karua Pakwach bridge was constructed. It was designed between 1961 to 1963. When we were doing inspection, we managed to have a look at, and we got the reports from Uganda Railway Corporation. They have all the reports. So we went there, like Doctor said, if you want to dig deeper into these bridges, it is very important you get to know the entity in charge. And then when you request for the information, they can trace in their archive and give you, so that you are able to understand what was it in the mind of a design then. So you look at it and compare with construction and compare with maintenance. So this one was designed, we believe it was constructed around 1964, together with the Roma Bridge. Now, a bit of a story about these 2 bridges, very interesting. These bridges were used in Wales in 1945 to link, I told you, to link and connected world. That was the war. So when the UK government I think were fighting during the World War, I don't know they were, these bridges were used. So in 1954, when now, prior to our attainment of independence in 1962, I think there was a visit by Queen, and then I think they started linking the different administrative offices, like the northern part, the western part, the eastern part. That is how the Nile Bridge was constructed. Then then they had to link the Kayunga and side of Kampala. Then they had to link the Busenyi side, the Shaka side, and the Kasese area. Then another bridge called Okolo Bridge on your way between Nibi and Arua. So you also go, you find similar bridges. These were all brought. Now you imagine, we also look at these panel bridges as when we get into the redesign, you will know these bridges are designed to last for about 100 years. So this is 100 years to 120. That is the design life, but service life should go more. We start when you're in maintenance, but at least you need to know. So someone may ask that if they were using 1954 or 45, and up to now they're still working, what happened? So you are going to, with your further reading, you are going to also see that the kind of traffic loading you have and environmental load we have in Western world is different from environmental loading and traffic loading in Africa. So you may find that's why longevity of bridges in South Africa could be far, far much better than the other side if maintenance is okay. But if maintenance is not okay, then also will be cut short. So this is a big story. So that even tomorrow, when you are looking at those bridges, you should know most of these notable steel bridges you see in Uganda, they were all airlifted from UK. If you go and check, they always on the side there, you find written on it. It's used in Wales, 1945. Then second construction now in Uganda. That's how we got to know about their history. You have Pakwach Bridge. This is across River Nile, linking what they used to call Gulu and Pakwach, but now it is Noya and Pakwach. And this is the proximity to the park. This Tange Gate that keeps flooding every time it rains. So I think with time we also look at that. You go look at climate change, adaptable structure. How do you many things that come. Doctor will guide us on that. So this is your Katunguru. You have the George, and then you have what? You have the Edward. Then you have cantilever bridges. Cantilever bridges, like they're telling you, they are saying it is built using cantilevers projecting horizontally into space. If you look to the right here, what these guys do is these are not normal. Actually, we are going to learn about pre-stressed concrete and reinforced concrete. So you can look at it and say, how did they do it? So I know Dr. will also attest to that. During our time, we learn about reinforced concrete, but we did not learn about pre-stress. You read on your own. But now, where we are going and where we are reached with population outburst and interconnectivity countrywide, there are areas that demand for long span bridges. Even for you who design building, we are not going to be having columns at only 6 meters. You are going to have free span of only 20 meters and design. So both columns and slab will be also pre-stressed. And then in the pre-stress, you have what they call post-tensioning and then the pre-tensioning. That one we'll learn later. So here, what the meaning of projecting horizontally means, you first build the pier support. I have told you to read the different elements. A bridge is comprised of the deck, is the horizontal member, this one here, where traffic use. Then you come to the support system. That one we call it structure. So the deck system comprises of asphalt, concrete, walkways, safety guardrails, and the either beam system or arch system or either of the two. So that is the deck system. We call it deck system, which is horizontal. Then the pier supports, the support system are vertical. You can have, so these are the support system. We call it substructure support system. That's how they call it. So when they talk of substructure now, you can now talk about pier. It can be pier column. You're going to see other support or a pier wall and so on. Then you have structure foundation. This is now the one below ground. It can be spread footing or can be piling. At least from your knowledge of structures and buildings, you at least know about functions. They do. Of course, there are also questions and other things, but that one will come with time. So once you build this support system, then you build a platform and you begin to construct in a cantilevered format, projecting outward. And you know the theory of design of cantilever and the path of cantilever and the behavior, the deformation pattern. It is thicker and stronger at the support point and then tends to deflect more toward, and you can see how they have narrowed it. So you build it panel by panel, balancing left and right as you come in, and at the same time you're also doing this side until you We are going to look at those construction things. And if you leave this engagement now, you can go to any YouTube. Just go and Google construction of a balanced cantilever. You are going to be amazed to see how they do it. So those are also spanning. The span range is about 60 to almost 300 or even 400. We learn about the span range and then you see what to do. About 150. So it moves again 60 to about 150. Clear span. So
yeah, Michael, one observation one can make there is with the span, the structure is more or less an arch, like mini arch.
Very good, very good.
So as a student, you need to understand how arches behave. Okay, much as they are cantilever, but they're forming like an arch, which is I think is also an important feature.
Yeah, that feature is very important. They need to do it. Within 60 meters to 80, sometimes they make it horizontally. They can make it the same depth. They call it uniform depth. Then as the span more than 70, 80, then they begin to do. Then this is now where you go to. If it can never be reinforced concrete now, you are going to use element of reinforced concrete, basically reinforcement bars, but you also have additional cables, post tensioning with the strength of 18, the stress of 1860, 5 times the normal strength of your normal steel bars. So we can learn about that, and you'll be happy about this one. Like Dr. stated, it's important. Why is this shape? Look at it also and look and try to see. There are also requirements in the manual, which I'll also look in future, that if you are dealing with a cantilever, so basically, don't worry. And even when you go now, you're going to look at span depth ratio for all this one. Actually, this is another assignment for you. One, read about structural component of the bridge. The second one, read about load path. The third one, look at span depth ratio. You have seen from Mosley and Cohen and Ivan, they all talk about, is it a beam, rectangular beam? Is it L over D? Is it 20? And then a T beam, is it 18, 7? What? A cantilever, is it 7? Or now even bridges do have the same thing. So go and begin looking at those basic, but they are very important. At your initial stages of design, the first stage, the step you start taking when you're doing those concepts is to look at span depth. What is the height? So you look at the span depth, and then you go into material type, and then the weight and the rest of it. So this is a kind of recap. We have looked at the different types and form of structures. We have beam, we have arch bridge. Each of them have different types. Even this one where we are, you also have steel. They also steel cantilevered. You can design, and you have your depth here of truss system here higher than as you go towards the middle point. So you have the suspension bridge, you have the cable stayed bridge, you have the cantilever, and I think this one is the steel truss system. Now the steel plate girders get into the beam type. This is the truss system. So those are different. You can use your steel plate girders to form the truss system depending on how wide the section is, and basically you will also look at how steel girders can be used to form box girders and get into something else. So that is the definition of a bridge types, and then the significance of bridges. They look at economics impact. Now is more reading. You guys will read a lot. So economics, it facilitates trade and transport. It connects communities, enhancing accessibility. We have talked of connecting unconnected world. So you can see now, if Karuma breaks, if the Nile bridge gets washed or it collapses, what happened? Mobility is stop. Everything is messed up. Education messed up. Politics messed up. Economy in trouble. So that is why it has to be. It connects community, even issue of health, and then enhance that. Then social impact. I've already told you, improve connectivity and mobility, support emergency services. And this is now where you can read many things and add on. Environmental impact. It minimizes travel distance reducing fuel consumption and emissions. Of course, now issue do with fuel consumption. Guys, some of you have done economics and rest, you know how to do that. Actually, when they're doing those appraisal of bridges, we call them appraisal. For you to get one type to design, you first look at 2-3 types and you do appraisal, like what they do feasibility. And then you look at all those multi-criteria things, the economics of it, the constructability, maintenance, and then you do. Now, issue of emission now, these are now environment. Also, you need to know that these days, in our days and before our days, it was engineering, purely engineering. But today, even to manage stakeholders, people who are affected by the project, if you don't manage them, you will not build that project. You will not successfully handle that project. The issue to do with politics must come in. So there are quite a lot of environmental. Now here the NEMA, there is a design aspect. You look at mitigation measures. How will the construction affect or impact environment? And then during construction, how will the construction processes affect the condition of where you are constructing? If it is a freshwater body, like Karuma is located in a very sensitive ecosystem, the Japan government almost refused to fund it. You're going to look at a model there. And they're saying because we already had a bridge since 1964, they're allowed to put a new one just above that one, just 20 meters downstream of that one. Otherwise, they would say this is bordering settlement, bordering park, bordering forests. So there are species that should not be endangered. So that's how environment becomes key in deciding and coming up with a bridge. So these are some of the things you do. Now, today as a student, you do your work, you have a group. You may be 4 or 5 of you doing the same civil engineering course, or your master's in design. But when you are designing a bridge, you have these categories. You see, number 4 has quite a number of people here. The expert involved to have one bridge design. I'm going to give an example of the Nile Bridge, or even this Kampala flyover. When you cite Kampala flyover, then look at this. We need civil engineers, and you know what civil engineers do. The guys who do design for your roads, because these bridges, actually a bridge, by the way, let me also give you another point to note. A bridge is a road, is part of the road. The only difference is bridging a gap. Otherwise, you would have come with your soil to fill all the valleys and go, but it has cost aspect, constructability aspect, and an environmental aspect. So you can't do that. So what you do is, if the road is at a super elevation, if the road is going down, is going up, the grade is sloping up and down, the bridge must depict or reflect verbatim the shape, the geometry of the road, profile of the road. This is what I need to know. Otherwise, don't go and design a bridge or always the same founder, the same support height, abutment all the same height, 10 meters. No. If you are sloping up, the first abutment may be 10, the next one with the slope given might be 10.25 or 11, depending on the slope of the road. So if it is being curved at that super elevation is what you design. And you must, because you cannot give, if you give a different shape, then that will become a black spot and become safety. So in your design also have to think about. That is why civil engineers are very important. You look at the overall design and structural integrity. Then geotechnical engineers are also needed, because in the Bible, you talk about standing on rock, you build on rock or you build on sand. You know what happens. You build on sand, you sink. You build on rock, you be there forever. So this is also captured here. You need these guys to understand the soil stratification, the soil condition. What is it? If the soil condition below 10 meters and beyond is not good, and rock is maybe 20 meters down, that's where now you come up with what you call pipe foundation or any deep foundation you need. If it is shallower, then now you may decide to go using spread footing and other type of footing. So the only person who gives you that knowledge for you to be able to model and design is the geotechnical guy. So it means now if you leave campus to tomorrow and your employer said, or your boss said, can you design a bridge? He says, yes, sir, thank you very much. I need to. You go down. You craft your work plan. You say, okay, I need the following stuff to be done. We don't have them. We can hire. Then I need ABC because I need them. As a structural engineer, I'm on at the tail end to wait to do the design. Then also the different activities. You're going to see activities required. So you begin to look, and I've told you it's not only mathematics you do and design. You must do some coordination as a designer. Who does what when? Which information do I need to feed so that the other person does his part for the other one to start his design? So there is a lot of management even at the design stage. So hydrology is very important for us, and water flows, flood risk assessment, even score. You learn about score depth, the general score and the local score around peer support and the rest of it. So the hydrologists always determine the catchments, then they determine the discharge through the bridge, and they give you the openings. Now it is from the opening that now you come up with your knowledge of configuration, and then you come up with a design. Environmental engineers, I've told you, you need it. The impact assessment need to be done. Impact of the construction to environment need to be assessed. If you work with these guys, you will be amazed that there's a lot of species, a lot of what they do to make sure environmental impact assessment is passed by environmental regulatory body like NEMA in case of Uganda. Architects is important. Like the Nile Bridge, we had an architect. That Nile Bridge, you see, that shape, these guys, they took about 4 months to come up with the shape. They look at the culture, they look at what, so many things, the people in Uganda, then if in and Kampala, look at the different, they brought in so many things. They used calabash things, so many cultural things they were bringing. The architect they had to, until they zeroed down to that shape. One day I will tell you that shape, what that shape was, and they made a joke and people laugh. So that's how architects come. But this small you don't need. But even yourself, if you're inquisitive enough, you can become an architect, because a bridge modeling is more an art. So you can come up with something very aesthetically pleasing and also functional design. Functional design, yeah, exactly. The structural engineer comes in. Construction managers have to overthink construction processes. That one comes down. But then it comes to construction manager, there are quite many things. You even need site engineer, you need technician, measurement engineer, but that one we shall be learning as we proceed. So for design, we don't need this one. We would need a quantity surveyor. We need a surveyor. Survey is very important. The topology or the topographic or the contour area need to be known. And then it is the survey input, the survey output that fits to the civil engineer's input. Then the hydrology's output fits to the civil engineer, because you have to put a profile, and then the structural engineer. I think they didn't put a bridge engineer. So this civil engineer, they might have included all that here. So materials engineer also you need, because the different soil and concrete and steel, you need to study there. Material properties, and if you are modeling and you're designing, that's the first. After your model, the next thing you must specify the material. So for bridges, the material grade seem to be on the higher side because of their exposure condition. They are exposed. Building is exposed to mild condition, but bridges move from severe to extreme. So then that will also guide you on. If a bridge is situated in a place which is contaminated with chemical, if you have a discharge from chemical industry, the way you approach your bridge structure and cover, concrete cover and the rest, is different from when a bridge is somewhere in the remote area of Karamoja and Kisoro. You may find the soil properties, the chemical content is far below 6. Now go to they say, I don't know, you call it in O level and A level, this pH value. You see, now you need them as a bridge engineer, because if the pH is less than 6, my brother, you have to be mindful of early corrosion. So if you design a bridge of 100 years and corrosion just gets in within 10 years, that means within another 10 years, so 20 years, you see your structure failing. You see discoloring, spoiling, and debonding. There will be no bonding between concrete, because corrosion is setting and progressing and affecting the functions of the steel, which is important in providing tensile property to concrete. So now that is how the issue of why you need materials engineer on your side. Basically, but we shall talk more about the different players. Now, for data required, for you to design a bridge, okay, you have a team. These guys can give you the data. I've already told you. Actually, defining what they do, they will have to come. Even traffic engineer, you need to know the volume of traffic going through the bridge. You can even get to know the category, because for design, you're going to see the traffic loads. You're going to realize that these traffic loads vary. Heavy traffic, the smaller one, medium one, how many a day. So tomorrow when you want to design fatigue, or you want to do bridge condition assessment or bridge ratings, in which, because your bridge is already 40 years in service, it may not be carrying the same load that was designed 40 years back because of exposure to environmental load and traffic. You may find if it was designed for 50-ton trucks, by that time you could maybe 5 ton is gone. So it can only be working for. So you need to understand all this dynamic for you to move on. So this material selection and the behavior is very important. So expert involved, there are more than this one. I wanted to continue looking for it and then we shall get more and more. Pavement engineer is important because you're going to have a road. Pavement design has to be done. Asphalt, concrete, asphalt has to go. Sometimes you have asphalt on the bridge or concrete. So you for asphalt concrete need to be designed. So that's very important. For data, once you have an assignment now, and you have a team already, you are going to start brainstorming on the data you need. So as a bridge engineer, you play a role of a team leader. Then you're going to say for the survey, I need topographical surveys. I also need soil and geotechnical report. I need a hydrological report from hydrology guys. They give you the discharge. They give you you have done this hydraulics. There is hydrology in the discharge. Then you go to hydraulics, where now we do this the flow through structure. Is it laminar flow, uniform flow, is it turbulence, is it steady flow? Those are the things that I do now to look at the behavior. If there's any blockage downstream of a bridge, how does it behave where the flood water goes up? You get it? So these are some of the things. So geotechnical information is required. Topography report is required for the surveyor. Environmental report is required. Data from traffic is required. Geotechnical, they have to do boring until you reach farm rock. For boring, normally you have to go until you reach farm rock. So, and that will guide you. And then the soil property, every layer must also be given to you. And then normally technical companies interpret all for you, and then you, the modeler, use the data. Then I think environmental impact assessment and climate and weather condition. This climate thing is very important. We are going to begin. If you look at Kasese bridges, we always get problem because our bridges, we were doing bridges as though climate was number one, like in other parts of the country. Now today, we have very, 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 very sensitive flow of water from Rwenzori side coming. It's with boulders as big as 3 to 4 meters. It's amazing. One time maybe we shall ways and see. We can have to visit Kasese and have a look at. So then the design data, this one I brought to, but it's also good to read about. We have data, design data. We have load requirements, live load, dead load, environmental loads. You help me and read about this one. For buildings, we use a lot about live loads. When it is bridges, this live load translates into traffic load and pedestrian load. The pedestrian can be crowd loading. If it is near a stadium or in the middle of like Kampala where there's a lot of crowd, you're going to see crowd loading on Karuma. So you will know what is crowd load. So when you're dealing with the bridges, we no longer talk about live load. We talk about more of traffic. Of course, live load comes in like with water and arrest because of fluctuation. Then you can, but there's also water current or water stream. There's the stream flow current, the rest of it. So live load is more associated with buildings and dead load. Now there are two types of dead load in bridges. You have the dead load based on the section given. You sort bridges up without adding any amenities, without adding any other additions like the concrete and the guardrails. That structure that to construct it. The computers, the software gets the self-weight. That is now the dead load. It is the part, the structure built without any additions. Now, when you begin now putting no services, rails, walkways, guardrails, any lighting, one lighting poles, that because we call them superimposed dead loads. They are dead loads, but they come at a certain stage and then they remain permanent. So when you are modeling a bridge, which we're going to see in later date, there's construction loading until a certain time. So when now the bridge is as hardened, the concrete in 9% and the rest are done, then you start bringing these additions, making like we call it finishes. In building, you call them finishes. So that is I wanted to when this part translate life in traffic and pedestrian, and then there are also earthquakes. It is environmental loading. There are many, even temperature comes in. Anything you can actually Google and find out what they are, and then you have impact traffic, so many things, brake loads and the rest of it. You can still go ahead. I know at the master's level, I think you have some of it. Material property is very important. I've told you for bridges, you just need to be aware if it is reinforced, you have concrete, and the grade for concrete varies depending on the exposure. Grade of structure which is exposed to chemical, it has to be also enhanced. There could be needs for admixtures, chemical resistive properties need to be enhanced to take care of the contaminated state of the soil contact. You need to be aware of all that. So properties like reinforcement. Today, even building, I think we are now into T type, which is 500 now, 500 MPa, I think, and so forth. It used to be 460. But if you go and do testing, you may find even more than that, but that is specified. So the design data you can get from design codes, also standards are there. We shall learn give some literature down. But for design codes, I think, let me also come up here quickly. We have our manual. I've given up the volume 4 bridge design manual from ministry. Is an abstract of BS 5400, and BS, as you're aware, is already out. But there are also latest BSEN. So you now look at that, because the other one of abstract has loading dated as far back as 1978. Now that loading curve is no longer applicable. They are using the one of 2006. So if you use a BD 3701, then you get the right load. But we shall learn all those things, don't worry. Then Eurocodes also are there now. We are using Eurocode, but the ministry is going to find a way of updating so that we get our man also getting also the latest code that's applicable in this part. Then the standards is the same thing. Then we have our literature, we have our local information that we need. I know we have not gotten the national annex for Uganda, but I think some of you will participate. Getting temperature, in Uganda we have different, the different districts have different temperature range, different water rainfall, different soil properties, and even earthquake zoning do differ. The western axis is more active, is more dominant. The eastern is active second to the other. So those are some information. As you become a bridge designer, you should equip yourself with. So that is the required data for you to be able to design a bridge. Many more will come in. We have the bridge design process. I'm just hinting here, but I think time will come when we talk length about it and more interesting when they are dealing with a bridge. We shall also use some softwares, and you see the design process required. Understanding the role play of giving play, and also understanding that you need to pick is very important. With two, when you are given a task, you get confused, and your manager will definitely give you bad comment. So you need to know the interlink between the different areas and aspects. So when you're playing a role of coordinator, you know that at what point do I invoke this one? At what point do I press this red button? At what point do I press the green or the blue? So that is what you need. The design process, definitely you have to, first of all, they may tell you They may tell you the president can go for campaign and say, "Can you connect these people?" Then the minister picks the information, comes and talk to your permanent secretary. Before you know it, they are calling you. Please go to Agago and come and give the report on how we should build this bridge. That's all. It's different from a politician. It's you now to go look at it as a technical person and start crafting your work, how to work, and then the processes. This process have got also timing. So also in future, we're going to know how long it take to do feasibility. And in feasibility, what do you look at different options? Bridges, we call them bridge appraisal. But still, you can do feasibility, which is the same. You're studying different types, looking at cost, different factors to choose one which is economically viable and can serve purpose. Then concept designs normally comes within that feasibility. You can actually start with concept notes and conceptual design, whereby I've told you need to know span range, you need to know span deck ratios, the typical deck section, which is guided by the load geometry and the rest of it. So in this preliminary design, you can actually do more on from first visit. You should be able to come up with something like concepts. Then feasibility now requires a bit of some data collection, and different people have to come in. The economists will have to come in. I didn't tell you, economists is very important to look at the viability, economic viability of the bridge. Some of the bridges connect serious communities, and you have border bridges, you have inter-district bridges. So the economists is very important. There's feasibility, he has a say there. Then you have detailed design now, do structure analysis. This is now where you're very interested in. The real calculations, what you guys want. And modeling, structure analysis and modeling, very important. We shall look at that. We shall get a bridge, start from model, understand the geometry. Modeling and art. You need to understand the bridge component you're working on. You have seen it, the load path, the configuration. For you to sit a day or a half a day, model your bridge. Or 2-3 days. Once you model a bridge, you are able to put the boundary condition. Also from structure, you must know. And then from there, you run analysis and do your design. From design, then you do detailing. You need to have knowledge of AutoCAD and Revit structure for detailing. It's very important. Then the specification comes in, the safety and compliance check come in, and you're able to generate a report. So there are so many things you do at design first. So final design is where now you do review. Also, you have to think about quality assurance of your work. You can design, then you pass it on to another senior person to have a check so that you have not forgotten certain key aspect of the design or loading, or you have given a wrong boundary condition, the support system. So that need to be checked by a senior person so that you are able now to run them. Once you run your the model, you are now moving to the next stage of design. So you have done modeling is very important, even the application of loads. So then now you do review, approval by relevant authority, and then you do preparation of construction documents, and you build the bridge. So you have done we have designed the bridge, we have known the types of bridges, we have looked at the different players, and then the data required. You have gone to look at design process. Now you are into the construction stage. You see, as a designer, from your desk, you should be able to design a bridge, construct it, and maintain it. So there are certain factors that affect the bridge performance that you consider your design. The factors that affect construction that you must consider during design. So you can see that you are not a small person, you are a very, very big person. And if you just reluctantly pick few things and do it, you may design a good bridge, but you cannot construct it, and it cannot be maintained. So now in your research, you can look at maintenance requirements, access to inspective areas, so many things that we shall learn when we are looking at maintenance and inspection. Time will come, we shall have a very good interaction. We already have some, I shared with management some good on maintenance and inspection on bridges. So we shall get time as we go along to just understand this, because you who is going to design a bridge without understanding the aspect of maintenance, what I told you, there are different aspects of bridges and they perform differently. You don't look after them well, If one fails, you have distorted the load path. Once the load path is distorted, you have created an eccentric behavior onto your structure, imbalance of load or load flow, load movement. So definitely as a designer, you will not sleep. That's why when you're looking at an existing bridge and you see certain part already rusted, like a steel, that means there's already section loss. As a designer, you get worried. People will just say, no, the bridge works. But you as a designer, you said, if this area was 20 millimeters square, and now with corrosion could be 15, it means the load designed for 20 millimeters square no longer works at this stage. So you begin to relate your design knowledge and construction knowledge to help you manage inspection and maintenance of bridges. So that is what you need. So you're going to look at it. So now at construction stage, this is now where I think some of you might have, I think you have construction management department in Makerere, I think, where they teach you how to manage projects right up from mobilization through setting out earthworks, excavation, foundation works, column, the slab to the roof, and the finishes. The same applies here. So we shall learn more and more, but here is briefly about that. Number 7 is bridge construction process. Planning and preparation, site inspection and preparation. That one now is assuming that doctor has done the design, procurement has happened, now they've gotten a contractor and contract has been signed. It is time now for the construction manager to take a lead and start following and managing a project. Some of you may not go and work in the bridge design office. You will be a project manager. And this is now where it matters. And you do a lot of coordination role, a lot of risk management role, a lot of communication when you're a project manager or a construction manager. It's about communication and communication and communication. So planning comes in, you do foundation construction, excavation and installation. Can even now, you can actually jump down and have a look at, this is now excavation. This is, I'm giving you 2 examples. This is a Kampala flyover. Those pier support system you see, they were having four piles. These piles are steel piles, steel screwed piles with the concrete pile cap, and then you have the pier support. You're going to see it. So now you see on the excavation and installation. First of all, I want you to relook, check this thing again. This is not good practice. These people are down here, almost 3 meters below this excavation. They have supported the site. So if it is recklessly handled, it can collapse and people die. Now you look at safety aspect. When you are doing excavation, what happens? So you as a project manager in the meeting, you make sure your site engineer is on top of his game. The site engineer looks at the site foreman. The site foreman looks at the site technicians and inspectors. All the things must be designed for. And it is checked on a regular basis. So this is the foundation. Fortunately, you have seen after this area, and then this was now ready for them to start reinforcement works, and then putting and then coming up. So we have substructure construction. When I talked of foundation construction in a bridge, I have now told you can be spread footing and it is below the riverbed, or sometimes they put it at water level, depending on how we shall see as we go ahead. Anything below pile cap that is considered to be constituting a foundation now. So when they talk about foundation excavation, think about the spread footing or piling. Then substructure now is the pier support, abutment, and other supports above, below the deck and above riverbed or above pile caps. Then finishing and inspection. Installing deck. Now I've told you what you're installing there. There are a lot of things you do. Even services, you have to install them there. Sometimes they clip water pipes. So now in your design, there's an aspect of utility loads you can also put in. So that now in future, when they request, you just look at the report. If you are the estate manager, say, okay, I think the utility was considered up to this loading requirement. Therefore, if they are requesting to pass in a water pipe of 1 meter diameter, say no, we can only give you maximum of 300, but that's the load requirement considered for design. and you put in a factor. So now you look at the entire project from design, construction, maintenance, and its function to make sure it moves as designed. So now then you find installing deck, you have railings and other features like I've told you, services, asphalt, concrete, and then final quality and safety inspection. Normally they have to check inspection and safety inspection, then there are requirements those safety guys do. So a safety engineer is part of your team. You cannot assume all the role. For you have done your design, you have coordinated the team. Each of them will tick the boxes that safety has gone wrong, is okay, traffic is okay, geotech is fine, pavement is okay. For you just say okay, fine. Then now you are able to take a lead and submit the report to management. So this is excavation, and then they did the drilling. Here they are done blinding, ready to start the reinforcement bar. After that, they finish the casting. I think I forgot. I missed taking the that part foundation where they started this building the pier support. This is now you can see how the build is ready for the deck system. So this is the Kampala flyover. This is the finished part. You can see. So if you can look at that, you look at this support system there, and then you can quickly understand what went down here. And then the piles go up to about 20 or 18 down, 4 in numbers. They are 1.2 diameter piles. Now, there's something you need to know during construction: materials control and production of concrete. This area here, you can see these are concrete pump area, some area. You can see these guys have their aggregate mixing, what they mix every day. So concrete batching, as we go along and look at concrete technology, you are going to see that there is materials. It has to be material must meet the specification. Then there's going to be mixing of this different material. For concrete, we call it batching. Looking at the sand, looking at the stone, looking at cement, and maybe there's a mixture somewhere. Water. So if you have a batching plan automatically managed, then you feed in those things, it will control you, you do it. If you are dealing with smaller sites, then you have to learn by volume. This could be by weight. So now these are some of the things that even there's quality control on where to place, so you can see the site arrangement. If you can see these shades, these are what we call.
Michael, we have been at it for 1.5 hours. I think I can see you're halfway.
I know. I can. Let me improve. Let me move faster.
You might want to speed up so that I'm worried about your time. For us, we have time.
No. For me today with the young one, I have no problem. But let me now speed up.
Okay.
Okay. So this is the batching area where these are call them chipping bays. You have different grade sizes. You post so that they don't mix. You only mix them when they're already in the batching plan. So this is how you can see. So as a construction manager, you also need to know where to place it. How do you access it with a dumper? Where do you pour material? How do you go with the concrete batching and this truck to the thing and move? This is also security, yes, safety. Many things do happen. You can see they've done it. So this is a small, even the site office is there. How do you do it? So at construction, there's quite a lot you do. That was that. Now this is Isimba, the bridge linking Kayunga and Kamuli near the Isimba Dam. You can see these are the other one. You can see it is the column shape is different. When you read, you're going to see different type. This is the columns. The circular one, I think 1.5, 1.6, and you have a color beam and have the pile go down. So the pile about 1.6, and this one is about 1.4. So you build it. After building, you also have a yard. This is This is the deck system is here. There are multiple girders. These are the girders you see, box girders. These are pre-stressing system. This is a jacking force. So we are going to learn about pre-stressing concrete. So these are how many? 1, 2, 3. There are 6, and there you have 1, 2. There are 8 of tendon. This tendon has about 14 or 12 of cables. Each of these cables have what they call strands, 5 millimeter wires of 18 MPa. We shall learn about that. So basically, in a nutshell, this is a seam bridge, and this is the construction. The yard, you can see a mold here for each of these guys. This is the mold where you put once you have done reinforcement, you put a mold and you cast concrete. This is how the concrete look like. Now, this is where you put the concrete up using these overhead gantries. You place these girders. There are, I think there are 4 in numbers. Put them, and then now you work on the slab. So that is this is the lighting you can see. Now there was water diversion, that's why it's dry. But now when you go to a Simba, you'll not see anything like so. They remove it and what has reclaimed this area. So this is the yard. This is the during construction of the deck system. This is the tensioning. Post tensioning, you're going to know what does it mean when you say post tensioning, and when it is pre tension, what does it mean? The post tensioning, you first construct it. After you create the duct, and then when concrete has gained 90% of the strength, then now you can now put in those cables, and then you tension using the ducts here. So this is now where the tensioning and locking happens. So now we're going to look at pre-stressing. How does it work? The reinforced concrete you do ultimately limit more, and you are not worried about serviceability, but in pre-stress, serviceability loading is important. This can create cracks, and cracks can initiate corrosion. So you must control all those things. So that's the benefit that we're going to get the basics from. So this is a Simba dam. It's 890 meters long. It's linked by an island. I think we are going to see a picture down, which is the entire thing. Then here is Para Bridge. This bridge is linking Masindi and Noya at Paradoch. That's downstream of Macron Falls. So this is now how do you access? Someone will ask, how do you construct foundation in water? You must construct a platform. Being a water body, we do still jetty. Allow water to flow, and you build a temporary bridge robust enough to take on the weight of equipment that will be plying that thing for the construction period. If it's a 3-year period, that bridge must be designed for more than that to be able to withstand the weight of drilling equipment, trucks carrying concrete and the rest of it. So this is a jetty across, supporting construction, then later it is removed. Here now they're working on the deck. You can see they have crane helping them to lift certain things, concrete pump is there, and many more. We shall learn more. So this is what is the construction. This is now construction, but still the designer must follow, because you must check this is construction to ensure that reinforcement spacing, reinforcement sizes, the grade, the shape of your girders, everything complies with what you have modeled and designed. If you don't inspect during construction, then they can make changes, and that means the design and it will be the behavior will be different from the of design. That's why the engineer must pay special attention and your site presentation. So you are not detached from construction. So you can see now they're building using this crane. They fabricate this in a yard. This area, that's where they fabricate the ladder. Then they will use a low bay truck to transport it to a good place where now, like, they will bring it here, then they begin somewhere up here, level, then now the overhead gantry, like what you're seeing down here, begin now to lift. If you go to YouTube, you are going to get very good video on how these girders work, and you'll be appreciative. So these are now the work on the deck slab reinforcement. You can see this is the contractor supervisor. Before the inspector comes, the construction supervisor is already checking that this guy, the steel bender, is doing the right work. Here now they did the casting. These are the girders you see. These were T girders. We shall also learn about, and we shall look at pictures later, not now. So these are T girders. Then from the T girders, they're precast, and you can see there's no formwork. So they form part of formwork. It's designed to take care of the formwork because of these water bodies, and the spans are 40 meters. So they put that, and then you cast this, and you have no propping like you do. Palaflower was propped because it's a dry area, and the spans were not as big as that, about 24, 23. So
Michael, maybe you could say something about the connection of the girders to the piers. Are they just sitting on, or those tensions, those tensioning?
Okay,
Are
fine.
they like how is it? How is the girder on the pier supports?
I think for I see, but they are sitting on bearing. Okay. We are going to talk about bearing. Forgot to mention on the bridge parts. We have where you have integral connection, where concrete is integrally connected or monolithically connected to the concrete. It takes both moment, shear, and tension. So you find this one, they have bearing. So elastomeric bearing is more continuous, but there is discontinuity between the leg, a disconnect between the deck and the pier support the bearing. So they are sitting on bearing. So that and they are safely supported.
So the pier supports are taking just vertical loads, not moments, right?
No, not moment. Moment can also be transferred in a way. If you do it, not you have to know what the wind there is a tractive or braking force from vehicle is all transferred onto the pier support system. And then, but of course, when you're using bearing, it is only vertical, but not only purely vertical. You must also subject it to even earthquake. This area was also checked for earthquake. You get it? So, but you don't fix that connection. You don't fix it. It's purely from a reaction. You're going to get horizontal. You're going to get vertical, but no moments. No moment. But at least the horizontal load will affect the function because it behaves like a cantilever system in that exactly. So that was what. Yeah. So that is that. And then for maintenance, I've told you already. What you construct must last for over 100 years. But how do you ensure it? That's when you do regular inspections required to identify any defect arising. So that you are to wait for 10 years to check, and the crack has really created start become and also expensive to arrest inspection. So inspection where we do the normal visual inspection, we say none about that. But at least you need there is structural health monitoring using these other I think they have sensors. Like those who have gone to Ginger, we're going to learn that they monitor those and the temperature effect on the wind and what we did not do there, we did not put sensors in the foundation to see the foundation. So, but at least for the cables, we are able to know the load being transferred from the traffic onto the cable. The sensors are there, so you are able to monitor the health of the bridge. So that one is a modern thing that you shouldn't worry. We look at it. Preventive maintenance, you have cleaning and painting. We have painting normally happen a year or two, depending on the quality of the paint. But cleaning should be on a daily basis. The way guys clean this Entebbe Expressway and Kampala here, that's how you should maintain the health of the bridge. Cleaning drainage system, you should avoid pushing any because the surface of the bridge is contaminated because of tire friction and also drop of spillage of oil. So whatever when it is in that water is not clean water like the rainwater. So it gets into if there are cracks into the reinforcement, then it can initiate corrosion. So you have to be mindful of whatever happened on the bridge. Repair, rehabilitation, addressing structural damage. So it is arising from inspection you are able to attend. Then you can see whether you repair, minor repair, major repair, or rehabilitation. So you are going to sit down. We did rehabilitation of Karuma. We checked, we inspected, but then we realized the cracks were too much. So it was required that we remove the deck and replace. So these are all new reinforcement. The put is so I told you can see reinforcement. That means you must check out the designer. This pipe you see here, this is you have seen concrete pumping. This is one way of transporting concrete. They could not reach the other side because it's about 84 meters. So what they did, they placed those pipes horizontally on the tires to go across. So now they start pumping. You can see the pump is here. This is where now the concrete is poured and moved through this pipe going all the way there. We cast this thing for 16 hours. The entire 80 meters was done. So that is the kind. So this was strengthening. I think more work. We are supposed to fix the expansion joints and then put lighting and then put the parapets and everything. And some few works are still remaining. But because of the pressure to use the bridge, it has taken some time. At the commissioning stage, you can see what happened. This is now excited crowd. They are on the bridge. So if it is a footbridge, you guys have started. It's subject.
So is that the live load, the crowd load, or the head load?
This is from pedestrian. This is now the crowd load you talk of. So it's about 5 kPa. The code allows you to limit at 5 kPa because this can happen. If there is war, people can go. If there's any function that, like if your structures are near stadium, where there's a lot of excitement, this is what you expect on the bridge. And it can create those, you guys will do dynamics, if a resonance happen or what on the structure like foot bridges, definitely it can go into something else. But we shall get into that if you look at vibration and dynamic response of the structure. Now, quality controls at the time of casting concrete. You guys, you have read about this. We shall not waste much time here. This guy is, what the guy is doing. Is doing a slam test, workability test, and their requirement, if it is a collapse, shear, and then is it what? There are 3 types. You can look at it, then you measure. Normally it is specified. For concrete, using PAM, it has a certain amount of slam to use to measure. If it is going to be heavily congested, you need flowing concrete. It also gives you the amount of what is the slam you should measure. So basically, that is exactly what happens. So in every site, you might think about quality control, supervision, compliance with design, compliance with the law, compliance with best practices. So as a bridge engineer, that's what you are. Case studies. I pick few things. The Nile Bridge, it is a 525 cable stayed bridge. We shall learn about cable stayed. 525. The site of Mjero is 100 meters. The middle span between the two towers, I think it is here. Let me show you. The middle span between these two, the 2 towers there, it is 290, and the other side of Ginger is 135, giving you 525. Nambigera Bridge, this is one of the longest bridge across the swamp, Nambigera Swamp, as you are going to Entebbe. It is on the Entebbe Expressway. At Busega, we have 2 types. You have two links. There's the Nalokolongo point, which is about 800, and then we have the one at Busega, about 400. That design type is typical of a Simba. They have four box girders, and it was the same contractor who work on the same. And so that's about 1.45 kilometers, and it is down here. The spans are 25. This is a friendlier construction to environment. If you were to do embankment, how much destruction would you have made here? It was going to be a disaster. So that is one of the things, consideration of environment in our design. Then we have Nalobare Bridge. This is our oldest in Ginger.
Michael.
Yes.
On that Entebbe Express Highway, there are some slopes which are really so deep. Curves, vertical curves.
Yeah. Now that
where they have to actually warn you to slow down. Mm-hmm.
Now that is why these youngsters are going to come and make some adjustment in design, because we have also registered certain cases there. So steep slopes, I always see steep slope. Be aware. Definitely.
I'm saying this because you advise in your statement. You say in one of your earlier statements, you said you have to align the bridge to the road, right?
Yeah, very good. But normally that bridge to the road must have a valley. So that slope you may or may not get that. But yeah, you are right. It has to be aligned. You are right. Currently, we have one scenario in Kingfisher where they from Butole, Besuruka to down to where they have the drilling activity. It's a very steep slope, and they put a bridge there. It moves at that, but it's not very steep like the one you are talking about. Fortunately for the Entebbe Expressway, those steep areas do not have what? Bridges are basically at the Nalokolongo low-lying area and Nambigera. The rest are overpasses. Yeah, but
maybe they needed to do arches, right?
Because they cut, these were man-made. Now you see, we are going to learn more as we go. It is cheaper to construct this that type you see, and arch is expensive to construct. The constructability, and when the project is really expensive, economy is very important. Sometimes your design is inch on economy. Then you look at it. When you do value engineer, they tell you that your structure must be functional at the least overall cost. That is it. You can look at all the different materials, all the configuration, but at the end of the day, is it fit for purpose? And this is the lowest money? Yeah, let's go. So you are right. An arch bridge could have been an option, but the question is how it would be. Would cost that project cost the whole of it cost about $487 million. It was one of the most expensive. If you go and Google it, will tell you one of the most expensive roads in the world. But I like that.
We are paying for it a lot. So
no, these young guys are going to make changes. Don't worry.
Okay.
So we have a Simba bridge. We have already seen is 890 pre-stress box girder. I told you there are two types of pre-stress. You are going to see which one. You have post-tensioning and pre-tension. Even post-tensioning has got what the external tendons and internal tendons. And then you understand. So we shall also understand that. So I think how does it look from the aerial view? You can also Google. It's this one here. So as you see now, this is one side. This is a cover island. Cover island is here, and then across you can see you cross that. That home you see the saying is closer to the former speaker. So for those who come from there, you can know. So this is the Simba Bridge, which is we finished. It was 2019 to 2022. It was done, and this is your Para Bridge, the one we looked at. And Para is 520 meters. Each span is 40 meters. But for that big rise, 25, and then it has expansion joint around maybe every 125 meters, five spans. The same applies here. You see this white area, these are expansion joint point. So you can actually look at 1, 2, 3, then 1, 2, 3, 4, 5, something like that. So these are multiple box girder giving you the deck system. And this is one of the peer support system. You can have a solid type, you can have a wall type. A wall and a column have different, you can read a wall and a column. If the thickness, if the width exceed maybe 6 meters, it qualifies for a wall. If it is less, it may be a column. So we can look at it and make correction later. But so you can have a solid type, you have wall type, and then column type. You design all to be adequate to take on the water problems, floating vegetation, and lateral load. So then you look at economy, constructability, environmental friendliness, all that look at. So these are the 4 types I picked, and they're all in Uganda. That's the good thing you guys need to. And if you come to your Ministry of Works now, and you need some of this information, you can get the design report, and you're able to do even some design calculation for some of the things there. You need them. If doctor gives you some assignment on that, you come and you get information, you critique, and then you're able to do that. Now, proposed projects. We have new projects. We have Karuma. This is the old one. The one I showed you, which they were working on. And this is a model. And I know these young guys should learn. I know you can model using Revit structure, you can use Archicad, you can use InfraWorks. I know these young guys can be very good. So this bridge is very interesting. You looked at balance cantilever, and there is what we call a cable stay. This cable stay is not a cable stay. This is called extra doors. We shall learn what an extra is. It's like a cable stay, but the tower is shorter than the one of cable stay. So what they have done here, because of cost and the rest of it, they have done half of the bridge. So the clear span is 120. We are not going to construct the foundation in water. You have seen how that water flow downstream of the bridge. So the foundation is going to be outside the dry area and then protected. So 120, the Gulu side is going to be 60 instead of 60. So that's how the whole thing is. It's as simple as that. They are doing the design, and by June next year they will start. And some of you guys can be attached to the project if we are still there. If not, even if we are not there, but you can, through your university, you can develop interest early enough and you start following the project. If the detailed design starts this year, you can also get involved with the consultation with them or with the doctor. You should be involved to understand some of the things. Now that is the Karuma one, is a new one. Japanese government is one funding on a grant scheme, and the consultant which designed Nile Bridge is the one doing this design. It's called Oriental Consultant Global. And then the next one is Masindi Port. We're also going to connect Renkunya or Kiriandongo with Apache district. And this was the proposed design in 2013. So right now, the consultant is doing this. This one is a steel box girder with a centerpiece of an arch. You have seen this arch is slightly different from the other arch. So when you go and look at different, you're going to look at them differently. So the system comprises of steel box open, and then it has a composite concrete. So now you have a steel composite. With a land composite bridge, and you will appreciate that's how it is. So this video is 140. So it has to take care of navigation. Also, you need to be mindful of navigation headrooms. So when you are doing design, some of the things are very important. When you interact with these people, you get to know where it is. So this is.
Yeah, so Michael, that's the question I posed to your minister, Musa Ichwero. Musa Ichwero. You know, that's a navigable waterway, right? Where ferries can move via right from Jinja up to Atora in Kambini. So when we have a fixed deck bridge there, and with is the design giving headroom for these steamers, the water vessels to cross?
Yeah, there are
sometimes you have a feeling that the agencies of government are not coordinated, because the water transport is a function of Uganda Railways Corporation, right?
Okay, fine.
And then UNRWA was kind of independent. This was the question.
But Ministry of Works, yeah, railways and UNRWA basically all of them are under Ministry of Works, yeah, transport system.
Yeah, but UNRWA seemed to be very independent in their work at some point.
Okay. Yeah, so you're right. Right now, I think they complained we were blamed on Para. Para is on a 6 meter. So the guys of tour guides, people were saying, investors are saying they're bringing in very big ships and it will not pass. But then we also did stakeholder engagement, and they are giving us a headroom which we use. But now we have realized that the minimum headroom we are going to be using for all our major water bodies is at least 10 to 12 meters. Yeah. But also you need to be mindful that River Nile is not navigable throughout. There are areas that, like this one is few meters to the Karuma Dam. And therefore...
No, this one is navigable, at least I know, up to Atora. Yes.
Okay, fine.
That's because if you get the history of the area, there used to be ferries right from Namasagari up to Atora. Atora was a landing site.
Because we are having ferry landing site in Kyoga, so maybe they had some link somewhere. I don't know. But River Nile is the link. It's not linked.
Historically, the last point of navigation is Atora in Kamdini.
I get your point.
Okay, beyond that, now you are entering Karuma, so you cannot go there.
Yeah, the good point to note though is that it's being reviewed by a consultant who is supervising that Renkonya Patch Road, and we have hinted to them that we need that navigation to be taken care of in the middle, at least to have at least a 10 to 12 meter from the high water level to the surface of the deck. Yeah, so this is 520. So we are we have initiated procurement for both consultant and also contractor. Then we have Laropi, those who go to Moyo, from Atiak to Moyo. We also have a proposal. There are two types of bridges there. Internally we are designed for balance cantilever, and this is your balance cantilever. Because it is 1.2 kilometers, I only pick a portion, but this is how it looks. And then here you can see it's not integral, or it's not monolithic with the pier support. It has a bearing. So now you can find like what doctor is asking. You cannot subject that point to moment. That point, yeah, it is only the support down here. So any lateral force here is transferred and creating. It affects the pile cap and pile and the bottom of this pier at this point. So you concentrate your checks and design more around here. Very important. Now there's another proposal to have a normal viaduct. This is the type. We call it like similar to the Isima, but it's called U-tap. The bottom one is what they precast, which can be post tension. Then the deck is cast later on in situ. In situ mean you place these cast girders up. Then now you prepare formwork. These girders will take care of wet concrete, construction loading, everything from up. So they are precast and post-tension. So then that's how they look alike, but they're different in construction and even in design. So this is another. So we may go in for this one. We have weighed the two and realized that maybe this might seem to be cheaper. But the question is, which my student or your student will have to do is here. You look at this. This is basically about 900 meters apart, and there are few foundations. But down there are 40 meters and many. So you may find that the foundation costs tend to be higher than the one of this one. But that is left at the design stage. For now, you're only understanding that they're there, but you must verify constructability, costs, functionality to give you a higher value for one choice to be taken.
So the option 2 is not a cantilever.
No, this is a normal beam, but they are continuous over three spans. So like after every 120, you put expansion joint. So expansion joint is also a component of a bridge. Please look at the expansion joint, add onto your parapet and cross barrier, and add onto your bearings. Those are part of your bridge. They are all structure. They must be designed.
Maybe you explain something, Michael. So these models and feasibility is internal to UNRWA, right? You do it internally. You guys do this.
What happened here? Sometimes if you are doing internally, it is a bit biased. It's not very good because now you can just sit in a meeting and say, let's go with this one. That's not real engineering. You get it when your employer doing it. But as soon as we brought in Arup consultant to look and say, okay, fine. We say, okay, look at the Viatac type, the U-type. Look at the balance cantilever. Try to weigh the two, check and see which one is as value for money and cost effective. Yeah. But normally the best thing for all our design we do at feasibility stage, at least 2-3 options must be taken on, and then you assess in terms of functionality, constructability, maintenance, in terms of environment. Then you zero on at least one or two.
Yeah. How about the data collection itself?
Data collection is what I've told you, because like these water bodies, you have to go, the DWD, they have to give you the hydrology guys. I've given you from that role play.
No, what guys, is, do you guys collect the data yourselves and hand it over?
Okay, no.
Or the consultants gather the data. That has a bearing on
the consultant is good. You know, sometimes if you say you are the one to do it, if there's delay, then you have created a claim case.
Okay.
So now sometimes you are busy. Michael is sent to maybe in the Karamoja for 2 weeks, and in that 2 weeks the data required by the consultant has never been provided, and therefore you have affected the delivery timelines, and so they are going to bill you for more time and more cost, which is not allowed. So once you give them to take responsibility to collect data, you give what they call introductory letters. They go with it. They know what they require. You may, as an employer, you can get a wrong data, by the way. But for them, if they get a wrong one, it's at their own what? At their own risk. Yeah, so data collection. Sometimes for the road data, like for traffic, we give because we are in charge of, we have the mandate for road development and maintenance. Yeah. Challenges. You talked about challenges. I pick few, but there are more. First of all, I start with where you are. If we left Makerere, we left many other college, we came out, then we find they're building bridges. And we learn on what? Buildings. And the building design we had a group discussion in third year, and after that you may find you are 10 or 12, only 2 guys work on it.
You're saying the Mujugumbias project.
That's what I'm saying. After that you come out and you find guys are designing bridges. What I'm saying, those are challenges. So now it is you now, doctor, to start introducing this subject, this module as quickly as possible, so that many young guys, when they're coming, they're knowledgeable. There are quite a lot of areas for them to pick, and they're very sharp guys. There's a lot of model now these days, and the rest they can pick. They know computers. All you need is to have this exposure. You know, in bridge engineering, they said engineering is experience. You can never experience if you have never been exposed to something. So engineering is experience, and experience is what? Exposure. So I always tell young people these 3 words, that take it. So now environmental impact is more, this is now into the real stuff. Bridges need to be designed with minimum impact. Those are challenges affecting design. Load and stress management, that one also you have to do, that the engineer can handle that one. Material installation can be handled by the engineer. There are ways of dealing with that. Aesthetics can also be handled. My only problem now comes from number 5. That for the young engineers from year 1 to begin to understand introductory modules to bridges, even from undergraduate, to begin to understand, we don't have it. So now, as soon as the guys are done, a guy gets his A, easy first class, he comes out, they give him a bridge. Now, what happens? But you have an A.
Michael,
yes, so you have the lack of...
We are almost hitting 2 hours. I'm suspicious that maybe the time will, when it closes,
I will not
we will have to re-enter.
No, you will inform your student not to run home. It's about, for them, it's about to go home.
No, they won't run, but I'm saying in case you go off,
so I limit, let me finish and then we wait for interaction. Okay, doctor. So
we just have to reconnect. Yeah,
okay.
we just
local expert is a problem. Now we have that challenge, but at least now with few people who have got exposure, now I think you're going to get that, and then that's where foreign coming in, they are dominating the industry. We have lack of proper and better design softwares. Now at least we have, because they're expensive, but at least now Maintenace is coming in and other things, and spreadsheet tailor-made, they're also coming in, making it easier. Site and exposure condition, I'll talk about it. You really need to do an in-depth study to understand that. So it's also important. Most universities in Uganda and East Africa do not introduce or teach bridge engineering at undergraduate and also master's level, making it probably difficult to design locally, always depending on foreign expert, which is expensive. And also, we limit our exposure of the youngsters, because even when you send them to attend design or construction, they will not show them everything. So that's what you need to, and many more. We have construction challenges. Now, these are okay, you can look at it. These are very literature, site conditions, you have weather conditions, you have safety aspect, they're all given here. You should be able to, you should be able to look at it. And then we have coordination. Effective coordination among various teams is a very difficult thing. It looks simple, but you have seen that different players have input, and they're all interconnected. They are sequentially or parallel activities. So you must also understand MS project. You must plan and know the delivery time, who has what, quality control has to be there. Traffic management is very important during construction, diversions and managing traffic to avoid accidents at the construction site. Lack of local expert works on works and machine operation is a problem, and most of them come from out. So these are things that these youngsters can begin to assess and even write a paper on that one. Lack of capacity and capability of local contractors. Most of our contractors cannot build bridges of this nature because they're not exposed to, local staff are not there with them, so they have to employ guys from out, which are also expensive. Always depending on foreign firm, making unit costs very expensive. Maintenance challenges. Use of wear and tear, regular wear and tear from traffic, weather, natural aging of the materials, inspections, conducting regular and thorough inspections to identify any potential issues before they become major problem. I've hinted on that. Those inspections have time. You have different type of inspection. You are going to learn when you are getting into maintenance later. So you appreciate repairs, timely and effective repairs. If you don't do it, definitely they cost $10 today. You make a mistake 1 year, you're going to pay now $10,000 and exponentially going up. Funding is also a problem. We normally get problem with funding. We depend on donors, and donors have become very expensive. What are some of the software that these young guys should get following? Look at Maintenace Civil. Look at CSI Bridge or SAP. SAP 2000, that's bridge component, very easy to learn. Maintenace is very easy to learn. Tekla, some of you guys, you can learn. I tried, but I left it. Robot structural analysis is for building, but it's very good for connections. When you reach the steel composite, there's a connection design you're going to appreciate, and also base plate design. Structural bridge design software is also very good from UK. Idea Static also is a good software. That's more of splice connections and all these other things. Even design or connection of these billboards and they use it. Sophistic from Germany also is very important, and many more. There are also spreadsheets from a professor called David Childs. If you get time, Google David Childs spreadsheet for bridges, get all the, but I wouldn't wish but to you to rush to that, but you can move ahead. You go to library, spend more time and get to know some of the things. So software is very important. And we are going to, with time, we shall use more of Midas. I've spent more time from 2018 using Midas to design, so I can make some introductory and also robot for that. And then, but we don't have a license. We have license for Midas. Since I used for some time, but now we don't have a license, so sometimes you have to be careful. Now, in conclusion, basically, what are the points important of bridges in infrastructure is link. You have to attend to the bridge. You have to, the way you attend to, I always relate it to our lifespan. And you are young, you grow, you become a youth, you can carry very heavy loads. Then there's a point now they say, hey, now you're 45, be careful. You start to go to regular checks. You're affected by now the same apply with the bridge. You build it to the fresh concrete, it hardens, then it is going to be exposed to environment, and then the strength reducing. The amount of load also reduces as the strength reduces. The same applies to us human beings. So, but when you maintain your body well, you don't expose it to so many unwanted kind of exposure and the rest of it affecting your life. Definitely you can live longer. The same applies to the bridge. So get to know. My key point here, please be passionate. Get to know, learn bridge components, the different definitions, understand the load path, the configurations, and the rest like design and construction maintenance will come later, but you need to understand this. What is this when they talk of an arch bridge? What are the key components? When they talk of foundation, deck system, get to understand the terminologies there. The bridge abutment, the bridge pier, the wing wall, the flaring type. Understand all that. Move everywhere. Get to learn so that the next time we have engagement, you have, and when we are talking of certain thing and you're going to model, you understand that. Then the readings, of course, there are quite a lot. I've just picked few things here. Designer's Guide to EN 1992, EN Eurocode Design of Concrete Structure. It has some examples. Bridge design. I think there's one book on mechanics of bridges. What you need to is talked about each element, how loads are transferred. If I get, I will share with Doctor, and Doctor will share with you guys. So bridge design manual, you need it, bridge what? So these are some of the few readings that you can look at. Towards the end, I think at concrete bridge design to BS5, for we start design, these are very useful for you. But for now, it may not be too much. Substructure is okay. Bridge number 5 is very good because it's going to talk about what we talked about here. Competition analysis also is important, is good. Bridges and the rest. Then reading and understanding the load path is important. Okay, Doctor, I think this is ends my interaction with my youngsters, and I think with that I come to an end and hand over to you to moderate. Thank you.
Thank you, Michael. I think let's all appreciate sign of appreciation to Michael. I believe this is the first time many of us are hearing a presentation of bridges, if I'm not wrong. So you consider yourselves very lucky. Michael, we are really grateful for this contribution from you. Now, if we want to take another 15 minutes and we hear from our students who wanted to venture into bridge engineering, maybe they will have questions for you, and then you can guide them. And for people who have research ideas, please bring out your ideas. In other words, in terms of questions, so that Michael can hear them, and then we see where we can. But for Michael, for me, what I see, where we can work like immediately. I know design is about new things happening. There is not much research to do there, but for those bridges that are failing, problem cases, can we like venture in assessing the integrity of those bridges by maybe doing models and see the kind of loads which are acting on it right now, and then maybe examining how critical they are. Okay.
That is possible because normally what we just come to us and then we get one or two. You can choose what bridge you want to do.
I am thinking, I saw you talked about Pakwach.
Yeah, it's a candidate bridge which you could actually look at. My only problem is,
according to what you're saying, the issue is the sediments are pushing the bridge.
right? And the bridge has now moved, is now disfigured. If you look at it, you join up. Yes, the expansion joint on the upstream is now widening, where the one on the downstream narrowing means the section that's really moving. So it will be better to capture it now, and then it's better now to look at.
You wonder what the stresses are.
Very important. You can
stresses are, and then the kind of loads. Can we like limit the loads? And then maybe smaller cars can. So that's the kind of information that we might be able to come in and help with. Okay.
I agree with you. You, as a university, it's very important. You just write a thing, you come and you end up in my hand because.
No, this is your work, Michael.
It
is helping you, like giving, okay. I'm not saying institutional level, but at least I think it helps even curiosity to know what is actually happening in there. If somebody can model these bridges and apply the load, and you see the stresses which are there and how the movements are working.
No, I agree. I think it's possible. It's possible. Yeah, it's possible.
That's what I'm seeing as one area we can work together. Then there is a case where a student, Gonzaga, you had there's a bridge called Manafa Bridge. It's a concrete, I think it's a beam bridge. So potholes, for lack of a better word, were developing in the deck. And someone did research there and said those are punching shear cases. I'm not sure whether that terminology applies in concrete decks. And so someone evaluated it from the perspective of punching shear. I'm not very convinced, but I wanted to get your mind. Is this kind of thing that you experience when a hole builds in the deck, a pothole in the bridge deck? What normally causes that kind of problem?
This is where it takes you back. You must understand the load path. You must understand the behavior of those bridge elements. When you design a bridge, and especially if it was, I know we inspected. Manafa is now replaced. It is but I know I was part of the team. But normally in between, and these guys are going to have a very good, and that's when that modeling you're talking about will come, because if you have steel composite, you have steel space at maybe 2 meters, and they're swinging between support to support. Now, what we call local effect. You see what brings about when you're designing, there's local effect analysis or local effect behavior and the global behavior. The local effect is transverse between the girders, transverse to the bridge. So it means localize under the wheels. So when you design a bridge and the girders have passed, you also need to check whether the slab between the slabs between the girders of 2 meters can also withstand both moment. It has moment capacity and shear capacity. Now, if you check shear capacity and you check moment, under the check in serviceability, you need also to know that the deck meets the crack is within the limit. Now, if the crack is not within the limit, and if the limit is 0.25 and you have a 0.3, 0.4, and because you saw amount of reinforcement is okay and shear is okay, you didn't check the crack. By the way, one thing you need to know is when someone design a 200 millimeter thick slab and capacity is okay, you can get reinforcement. You may check, and reinforce the T20. When you check the crack, you need T20 at 100 for it to pass the crack requirement serviceability. Now, when you ignore that, at the design stage, and you pass that, and the contractor implement. Now, remember, this bridge is going to be subject to other exposure condition, the different environmental. I've told you that the concrete is not the class required. Normally, we say minimum 40 MPa. If you check that bridge, you may find the grade was 25. Now, 25 MPa. Remember, bridge, even concrete is subject to fatigue. You know, effect. So every time the truck is passing on the bridge and those heavy trucks are passing, there is a vibration. This vibration area bridge is not robust enough, can propagate cracked to an extent that there will be dislodgement of reinforcement and concrete. There will be no bonding. Now, once due to vibration that you have, if the reinforcement are wider than required for the crack, and if instead of 100, the reinforcement you put 200, 250, definitely you're going to have concrete cracking along reinforcement, and you can see the pattern. And one day you're going to have an axial load, which is because failure is
progressive.
Very good. So normally, if I start cracking now, we fail in the next 20 years now. Because now what can accelerate is when the corrosion has gone beyond required, and so the reinforcement cage alone is trying to hold the structure, but because locally under the wheel load, you find that this structure is vibrating and members have started getting away. So it's not what they call punching shear.
No,
you don't call a punching shear like that. Punching shear is always considered by the designer. Of course, you can relate it to a punching shear but if you look at the global behavior and that local effect, it has a lot of interlink causing that failure.
I expect punching shear at point load point, concentrated loads.
Yeah, concentrated load is because and Robert is a rolling load. So you find a rolling load. It's for point. It is okay. Point load can create cracks, which can cause problem definitely. But now this one I can leave it to when these young guys get out there. You can load the section until failure. You can keep putting it and you check and see you load it. Like now the model you're talking about. And if you're using if we do fair and you do solid, you can actually see stress distribution. And you can even check then you are able to know that this stress generates this kind of. If this is the stress and concrete at I told you at here 50 or 50% here lifespan, the grade of concrete has really reduced, and yet you are having increase in what axial loads. Population is growing, so you have a mixture of many things. So as an engineer, it's always not good to jump quickly and say this is it, the actual problem cause. Because normally happen like if you have columns either at the footing directly below beneath the column or at the slab above on top of the column. So
that's what I was saying. Point load, concentrated loads that may be columns.
So this one now you may find actually there is the delamination. You have bonding problem from corrosion that to really taking because of, you don't know, because you need a condition assessment to understand that reinforcements were intact, concrete was still okay, and it was punching. But otherwise, if you have combination of corrosion and aging of concrete, then I have told you that it disintegrates under vibration. And so you just need one area to get off, then the rest start propagating and getting into
then the concrete falls off.
Exactly, because of that. And we also noticed that with Karuma, that because of that vibration at the site of Noya, some areas were already cracking, but not at a close range. And the reinforcement was spaced at 140. You can see congested. So it was designed to take care of crack. But if it's slightly wide, 150 and above, then definitely with vibration, and if there's any debonding due to corrosion, spoiling effect, the thing will give way. So it was not very good to quickly conclude that is punching shear.
Punching shear. So coming to that element of vibrations, like we know, even with the rehabilitated Karoma Dam, the Karoma Bridge, what could be, how would it fail? What could be the because I know there's a lot. I don't know whether you have the kind of connections you have. Are they like bolted connections or welded connections?
Okay, fine. But I think this one will be interesting in future if we look at steel composite, because right now it might confuse, but still I can talk about. Roma, you have steel plate guard. Those two you see on the side, they are 2.5 meter depth steel plate girders with top flange, bottom flange of about 700 meter width, and then you have the middle web. So then they're joined by close frames at every 3 meters. Then on the plate girders you have concrete slab of 300 millimeter. Now normally that slab should be connected. So the plate, because it is continuous across up to the 84, you have connections using splice connection, because girders have, these beams are 12 to 18 meters. Anything more than that, you must now do what? Connections. So this connection you are talking about for the flange and the plate are welded. So this guy is not about welds and weld size, weld grade, and how it can design can affect, or loads can affect the weld behavior. Then to connect the two in the bridge direction, you have to connect using what they call bolted splice connection. So this bolted splice connection, the flange has a as what they call connecting plates, and then the bottom flange also will have connecting plates, and the web also has got connecting plates. These plates, you have the grade of plate must be known, the size of plate must be known, and the balls. These balls can be in column kind, and so the row type. Then because of the force, they are placed away from high stress zone. Make sure the shear is low and the moment is also low for the balls and the plate to take care of bearing, shear, tension. They have done that in their structural analysis. At least they understand ball group behavior and the rest. So the connector is very, very important. Now, if these balls are affected with collision, that is a failure mode now that happens. Now, this also for the benefit of them to understand, I told you about the span depth ratio. Now, the middle span of Karuma is 48.8. So let's say it's about 50 meters. Now, span depth ratio of 20 meters give you 2.5. I'm looking at it like I simply supported. So my depth would be the length divided by the 20, which is LD to 20. In your mostly and Kong, it will be 26 if it is continuous, but I'm using 20 just for simplicity. But then the Gulu side is 16 meters, and they are using the same 2.5 deep girder. So it is conservative. So that girder also was airlifted from another place and brought just to connect. So that girder is so robust that I tried to model, which we shall share in future. You can reduce it. Actually, it will be 1 meter only, but you have it twice. You get it? So the only problem now with that is one, we discovered there is corrosion of steel. We have discovered, so there's section loss. We inspected those cross frames, everything, but I will get time and just make sure the load path and the configuration of Karuma you can allow. We shall get time and exhaust it so then to understand how Karuma was is put. Then they can put that together. We do a model and see the load distribution. Then also go further and now can critique any area we want. But my only worry with Karuma now is the bearings had problem, and the Karuma is on S curve. These guys are engineers. So the S curve, you have reverse stresses there. So that alone is also affecting when heavy trucks are joining the bridge, they are joining skew to the bridge. That's why the accident is a lot, because we need to turn. A bridge requires at least 50 meters straight or stretch, whereby when you turn full, you should be able to see the bridge you are crossing.
So, because Michael, if I can stop you there, that to me is a problem that we can study.
Okay.
Because yes, it is on a S curve. So what?
I'm telling you, Okodi, you subject those guys. Let them have a study on that. You are going to look at we look at the bridge itself, and then we can then say in future, because a similar bridge is coming up. If
we might be thinking about and limit the stresses, the critical stresses, and therefore we work it backward to the vehicle speed and vehicle loads, right?
Very important. I like that. And then
we make it a recommendation.
The slab is spanning.
I hope the students are hearing what we are discussing, and you're developing your own problem titles,
Very
right?
good.
Yes, we are
That's
in.
okay. Mm.
Yes.
And
So that to me is a problem we can say, because the issue is Karoma already exists and it's a critical infrastructure. Now there's a construction flow, design flow,
Mm.
in the sense that it sits on an S curve, and therefore the way the vehicles are approaching is generating stresses.
Very good.
We go direct to the bearing.
Yeah, we noticed that was very good. Yeah.
Yeah, so we need to look at the kind of bearings that we have there and their strength, and then we see, okay,
Very good. We already have
our
the bearing
models,
and
how
all
are
of
the
this.
stresses going? Yeah, so that's already a problem.
Okay,
all right?
very good.
Okay.
So, Doctor, what I would suggest, now that you have opened a forum for knowledge sharing, with time, sometimes some of these guys can pass by and physically interacting, and then if there are certain notes they want to share with some literature, you can share. Then, basically,
Absolutely,
absolutely,
and also you will give us your time now that you are coming into our system, because I told you this collaboration, we have to try and build that and have like an end goal where we incorporate bridge engineering in our university. Okay?
No, it's okay. Doctor, I think for you to give me this opportunity, I have an open door policy for these youngsters. I have been having a lot of guys being sent here, and you guide. I even currently have some students from KYU, and we have a WhatsApp group. And I always punch in questions. I put in. I have a YouTube. I've also started a YouTube, where they can easily also go and have a look at what we have now. A lot of story I talk there. They can be one of these Ochola Michael, and you look at box girder, steel design. You just get those things. But very important is I will get time and share the modules that I did for the university, and then you also look at it and what was there, what was covered, so that you guys can look at the content, look at what was covered, and you are able now, if you get expert and TA, they are able now to tailor it to suit your condition here in Uganda. But we shall share that. The issue of steel composite, the issue of bridge management system, the issue of pre-stressed concrete, long span bridges, durability of structures, and then steel building. I did steel building. I did soil structure interaction to see how soil behave when you apply load on, and then the rest of it. So there are about 8 modules. We shall get time and explain so that they can look at it, they can read it. You read while guided with some syllabus done by those Western world. So we shall get time and share that with them, and then get to know. But I'm happy. I will not have any restriction. Anything you need any day, you let me know. I'll put the time, and then I will attend to these guys. Very well.
Okay, so I think let's open the floor to the students to also speak.
Very
as we
good.
Wind up.
That's okay. Very good. Thank you.
Thank you, Doctor and Engineer Michael. My name is Gonza.
Yes.
I have a few questions, maybe to begin with.